Hello, everyone. My name is Luca Hernandez Acosta, and today we are talking about my work in progress paper, Multi-User Privacy with Voice-Controlled Digital Assistants. Before we head into the presentation itself, I would like to give a brief overview about the content that we are talking about today. In the introduction, we are talking about voice-controlled digital assistants, VCDAs in short, and how their popularity rised, as well as some privacy issues, especially in multi-user environments, and our goal and the steps that we need to follow in order to achieve this goal. Then we are talking about some related work that dealt with similar privacy issues and also came up with initial solutions to those issues. Afterwards, we'll have a short outlook onto the scenario we use or we assume in order to build our proposed approach. And afterwards, we will discuss also some shortcomings of this approach. Then we will have an outlook into future work and future research that has to be done in order to finalize the study. Afterwards, as a final step, we are finalizing this report with some concluding remarks. As we have seen, the adoption of voice-controlled digital assistants has increased in the last few years. And this is on the one hand side because it's intuitive and comfortable way of operability, but also because the AI technology where voice assistant is based on has also improved and now supports the end users in a various amount of everyday tasks, leading to its integration into the smart home and also the control of other smart devices. We hereby not only refer to smart speakers or smartphones, but also to other smart things such as TV remotes, thermostats, or cars where voice assistants are increasingly built in. While we do have this comfortable way of interaction, this intuitive way of interaction, we do still have some risks to privacy and user concerns that can negatively affect the user acceptance. One of this is the always listening feature, which poses the risk to some users that their voice is recorded 24/7 and sent out to cloud services, leading to a potential misuse of personal data as the data are processed not locally, but online on the cloud. Plus, additionally, by default, the data are stored indefinitely by most manufacturers or third-party developers. Besides these more general privacy issues, we also have multi-user privacy issues, specifically for VCDAs. And here we do experience some sort of privacy conflict between primary end users, the ones who initially set up the device, and the secondary end users that are relying on the primary end user to handle the data appropriately. And the only way to get access to some privacy settings in order to protect the individual privacy is by registering an online account. And in addition to this online account, you might have further information that is linked to it. For instance, your name, your payment information, or maybe your place of residence. While you have those privacy settings available, it has been shown in different studies that these existing privacy measures are only providing limited functionalities and are often too complex for users to adjust them according to their preferences. In our system model, I would like to highlight here the VCDA architecture, where we can see the four different stakeholders, the primary end user, the secondary end user, the manufacturers, and the third-party developers, where we have the voice-controlled digital assistant that is responsible in order to detect the wake word and to afterwards record the following voice command, forward it to some cloud services where it is processed and stored. And after the processing is done, a response is sent back to the voice-controlled digital assistant and replayed to the respective end user. What we see here is that the data is not processed and stored locally on the device, but it is processed and stored on the cloud services. Our goal hereby is to help the end users in multi-user environments to protect their privacy. First, by creating a local user account and storing audio recordings locally on the VCDA, plus giving the possibility to access local audio recordings with a smartphone and a wearable, all in order to protect the recordings from other participants in a multi-user environment. In the related work, we have seen that some studies have shown that some sensitive information can be derived from the voice, and that also initial solutions have been proposed in order to obfuscate the voice, to hide some characteristics in order not to be able to derive things like the age, the gender, maybe health aspects, and also filtering approaches that can be used to filter out sensitive words and replace them with less sensitive alternatives. Multi-user privacy, on the other hand, have only been theoretically discussed, but have been also addressed in first solutions that were built, for instance, in Google Assistant. But still, we do rely on user accounts and recordings that are still stored online. The scenario that we assume in order to build our approach on is a multi-user environment where we have multiple users that are interacting with the same device. And we would require all of our users to have a smart device, a smartphone or a smartwatch, in order to create a local account on the VCDA. And after this account registration and creation is done, the end users can then choose their privacy settings and therefore can view and review past interactions and also delete those interactions on their smart device. So in the first step of our proposed approach, we have this accountless authentication setup process where we are combining the current situation, the current setup process, and our proposed approach in A and B. We do see some similarities, but also some differences. One of the similarities is that we are using a companion application that is required for this whole setup process. But we do refer also on mutual authentication that is based on station-to-station protocol between the VCDA and the mobile device, the smartwatch or the smartphone, for instance. And we also heavily rely on a mandatory voice profile setup that is used in order to map the local user account to the respective user, and also every other voice recording that is shared with the VCDA. Next, in our proposed approach with the offline voice command history, we want to move away from the storage, the online storage of those voice commands in the cloud. And we want to integrate a storage that is taking place locally offline on the VCDA. On the one hand, because unregistered users might interact with VCDAs and the voice recordings might be openly accessed by other end users. And in our approach, the voice recordings are stored offline and linked to the respective local user account, where only the respective user then has access to and can review and delete the recordings via the companion app. What we do see here is that we heavily rely in our setup process on other smart devices, which only also says that we are excluding certain user groups that have no smart devices, such as children. A possible solution could be that we do not store any recordings for this user group, but at the same time, this would mean that we have less control over the data. We also need to further investigate on the usability of this new registration approach, and we also have to explore possible vulnerabilities in this new setup process, and well, we have to explore those vulnerabilities. For the future work, we then directly have to perform some user studies when the prototype is finished implementation. And we can then capture the mental model in our user studies of our participants, as well as we can explore if the prototype is usable for the participants and maybe even investigate if there are preferences in favor of our suggested setup process or maybe even the old email registration process. Finally, we do see that we have some common privacy settings for VCDAs that still only provide limited privacy protection, and that all users that want to have access to this privacy settings have to create online accounts. And in multi-user environments, we do see this privacy conflict between primary and secondary end users, where the primary end user has more control than the secondary end user. And in our new concept, we would need to create local user accounts and store recordings offline, where we would prevent primary end users to have more power about the secondary end user, and we would have less data shared with central servers that are maintained by manufacturers and third-party developers. Thank you for your attention. Here's a short list of recommended reading. And I am looking forward to your questions in the next few minutes. Thank you.